So in a real world instance, you have thousands and thousands and thousands of containers, these thousands of instances, and you see how easy they are to come around. We need some way of bringing them online, upgrading them, taking them offline. It's actually a whole job of people to do this. So we call this orchestration, bringing these servers online, bringing them offline. The one you've probably most heard of is Kubernetes. So you may have heard the term and you're like, what does it do? That's what Kubernetes does. It manages your containers for you. And as you can tell by us just creating one, and then we created another one, that's pretty manual. But if we use something like Kubernetes, or even Docker Swarm or Apache Mesos, we can create hundreds of containers at one time. They're all running the exact same instance of our application. And that's what we call orchestration. Obviously, we're not going to create hundreds of containers. It's not super practical for this instance. And Kubernetes is probably its own lesson. Is there a front-end master's course on Kubernetes?
Brian Holt's course, Complete Intro to Containers, gets deeper into Docker and has a section that covers Kubernetes.
Yeah, so if you want to dive more into containers, there's a course for that on front-end masters. It's a whole thing going. So I talked about it earlier. We have two containers now. How do we get Nginx to talk to it? We're going to use a load balancer. And we need a load balancer because what if one of our servers is overloaded? But we have two servers, but all the traffic's going to one. That doesn't make sense. Why do we have multiple servers? So we can tell Nginx, if there's servers running at 90% of CPU time, why don't we route the request to the one that's running lower? That way we balance the load across all of our servers. This is a really important concept if you're talking about multi-container deployments. There's different types of algorithms, and they're called scheduling algorithms for deciding which one it should go to. Round robin is the default, so that just means 1, 2, 3, start again, 1, 2, 3. There's IP hashing, so you're saying all IPs from this particular block or domain go here, all IPs from this one go here. There's random, implied, random. Don't really know what that one's good for, but you know. Yeah?
There's a really cool article on two random choice, choose the least. It's like least connections and least load. You have to sample over all of your servers. But if you have a lot of them, that might take a while. If you take two random choices and choose the less of the two, you get like a surprisingly even distribution.
Oh, yeah.
And you only have to look at 2 instead of 1,000.
That's good thinking. You take two random choices and then you parse those down to least connections versus getting the server load for each one. Yeah, that's really sharp, yeah. And one of the scheduling algorithms we can use is least connections, but again, there's a cost to, you have to know how many connections are on a current server. Then there's least load. Again, you have to measure the load of each server. And I've talked about load, but we haven't actually looked at how to see that. So run the htop command in your terminal. I'll go ahead and do that too. Htop. And that shows us a kind of nice breakdown of what exactly our server's doing. I want to say in Mac, the equivalent would be like application monitor? No? Someone remind me.
Activity monitor.
Activity monitor. I never remember activity monitor. I don't know why. And pretty similar concepts. This one's much shinier because it's the actual GUI. But this is useful if you're like, why is my server so slow? We can look at it and see, oh, there's a node process that's running. So we can just p-kill that node and we'll watch our server load drop. So right now our server load's pretty good. We're only using 0.1, 0.7%, and we have a lot of free memory full. So I just Control-C out of that. So htop is nice to know, see what your server is actually doing. So now let's implement a load balancer in Nginx because we now have two servers, so we can actually load balance from one to the other. So what we're going to do is we're going to create an upstream, it's something called an upstream, and that just says, hey, these are actually my server clusters that I want to connect to. We give it a name. We'll probably call this node backend or something like that. We give it a list of the servers that belong to that server cluster. And then in our server block, we just proxy pass to that server cluster, and Nginx will take care of the rest for us. And if we want to implement a different algorithm in that upstream, we can say least con, but we'll keep it at default as round robin. So let's go ahead and do that now.